I want to start by thanking a few people who aren't here and a few people who are here. First, my coworkers at the Gila Watershed Partnership. They're holding down the fort for me right now because this is our first week of implementation. I'd also like to thank a few people like Tim Carlson, the folks at Stillwater Sciences, and Matt Johnson. Without them, I wouldn't be able to be here and take all the credit, so thanks, guys. I appreciate it. So a little background, the Gila Watershed Partnership is a public-private collaboration serving Graham and Greenlee counties in southeastern Arizona. And our main goal is to improve watershed health in the Upper Gila watershed, but primarily we work in Arizona. So the Upper Gila has changed a lot over time, over the last 24 years since we were established. So as a result, the issues that we've tackled have changed over that time as well. So in the past, we have done projects working on sedimentation control and erosion control. We tried to reduce E. coli levels by establishing restrooms in heavily recreated areas. We pulled invasive Chevys out of the river. We've developed a watershed steward course at the local college and many, many more projects. But what I'm here to talk about is in 2013, we started a habitat restoration program. And I was brought on to coordinate and implement that project. So that unwieldy title to begin with, it really just breaks down to tamarisk control and habitat restoration. Our community is concerned with three primary threats related to tamarisk, those threats being flood disturbance, wildfire exacerbation, and the potential expected arrival of the tamarisk leaf beetle. So first, the flood disturbance. Tamarisk is choking the river, and simultaneously it's blocking the community's connection to the river. As the river channel is narrowed by the tamarisk root system, and also the woody debris that accumulates within the river, high flows are pushed out of the riparian corridor as flows back up behind block structures like bridges and rough vegetative surfaces. So here is an example. First one is an example of what we are pretty used to dealing with on the Gila, and I'm sure many of you as well. Very dense tamarisk. In comparison, here's a native cottonwood gallery, so you can see how the river would flow differently through these two systems. Tamarisk monocultures are also more susceptible to devastating wildfires. This is a picture from a wildfire that occurred in 2013 along the Gila near Bilas. And this is a picture of what that site looked like about 6 months later. Tamarisk is adapted to fire, as many of you guys know. So we've essentially created a system which was once kind of fire maladapted, and it used to resist fire, and now we've created a fire highway along our rivers. Lastly, there's the concern about the expected arrival of the tamarisk leaf beetle. And you can see that where we are working on the Upper Gila in Arizona is one of the few places in the West that we don't see it. So right now we're kind of hoping that we'll be able to establish a program that can mitigate against the future expected arrival of the beetle. So we are expecting to see the subtropical species of the tamarisk leaf beetle that was released in the Big Bend region of Texas. Now, I know there's a lot of studies out there, and you can probably refer to Ben Bloodworth or James Tracy about when we expect to see it. I think the safe bet is 2 to 3 years. We might have been saying that for 2 to 3 years. But I'm hopeful that it'll actually be 2 to 3 years so that we can have some time to get some work done on the ground first. So based on other watersheds' experiences with the beetle, we know that we can expect some adverse impacts to our southwestern willow flycatcher populations. This is a picture that I've stolen from the Virgin River in Utah, where you can see that this nesting swiffle is pretty subject to increased temperatures and also increased risk to predation from cowbirds and other species. As a steward for watershed health, we're obligated to protect threatened and endangered species. So the Upper Gila is one of the 3 most productive breeding grounds for the southwestern willow flycatcher, along with Roosevelt Lake and the confluence of the Gila and San Pedro rivers. We are likely the first of those 3 to see the tamarisk leaf beetle, so we're hoping that this pilot program that we are trying to implement on the Upper Gila may be able to inform future projects downstream and hopefully protect those species in the recovery of the southwestern willow flycatcher. So our first step was to get a better understanding of our river, and we investigated a 54-mile reach between the Gila Box and the San Carlos Apache Reservation. And I'm sure many of you have heard Glenn and Bruce talk about this. This is a presentation that's happened for several years now. But they used an assessment of 7 parameters to highlight areas that were best suited for active revegetation. Those parameters were pre-biocontrol veg and wildlife monitoring, shallow groundwater availability, soil texture and salinity, and willow flycatcher modeling. And with those parameters, as you see on the outside, we're able to determine some restoration site suitability models, and that came out to thousands of acres, and I couldn't hope to be able to restore all of those in the next 2 to 3 years. So they refined it to determine high and medium priority or potential areas. And with that, we were able to determine about 750 acres, I believe. So in this next slide, we can see the results of the model. The green is everything that's potential. The purple and the blue, the purple is the high, and the blue is the medium. So again, about 400 acres for each one. And for perspective, we're trying to do about 200 acres by 2019. It's taken us a long time to get through the Tamarisk monocultures there. So where we started last year was we put in a permit through the Army Corps of Engineers, 404 and 401 Clean Water Act permit. And we started with a pretty small request. Of all these sites, it's only about 54.3 acres. So we wanted to start small so that we can establish a process with U.S. Fish and Wildlife and the Army Corps of Engineers, such that we could build upon this permit application and then incorporate more acres in the future. Also, all of these sites were located on private land. So last year, during this conference, again, was the first week of our implementation. So in that first season, we threw the kitchen sink at the project, which meant that we had a lot of opportunity for adaptive management because there were a few mistakes made, but we learned a lot through the process. And hopefully you guys can learn from some of our mistakes. Because one of the things that I've been a big advocate for is a journal of failures, and I'm sure that more than a few of us could contribute. So this officially starts my partner advertising program. You can see from basically here on out that without our partners that we wouldn't be able to get much of this done. And we were able, through some generous funding from Freeport-McMoRan, which is a local copper mine in the Safford and Morenci area, to purchase an excavator. This is our excavator and a mulching head attachment, which we use to masticate the trees in place. So Freeport-McMoRan, again, has donated cash, capital, and land. So very thankful for their participation in the program. So not counting the initial investment, the excavator operation is also about 10% cheaper than running Arizona Conservation Corps crews. Now that's not to disparage Arizona Conservation Corps crews. They're imperative to our project. But this really makes it more cost effective for us to treat the sites that we have to deal with. So if you question whether or not we were using that excavator or mortars, this should hopefully show that our excavator can be pretty targeted. This is a rare elderberry. Well, I guess it's not that rare, but on our sites it's pretty rare. So we were able to avoid it for the most part and salvage it. And this picture was taken, I believe, March of last year. And this is that same tree in November of this year. So about 7-8 months later, we've been able to keep that tree in place, and it's going to provide great habitat for both pollinators and hopefully the yellow cuckoo. So we're using a tricloper mix. I know a lot of people use Garlon. We use Element, a little bit cheaper. And last year we used a 12% active ingredient mix. Now I say that our results were a little inconclusive, but we saw a lot of resprouts from our stumps. So over a longer period of time, we may have seen more die-off, but we actually increased the active ingredient mix for this year, and we're hopeful that we'll see a lot more, or a lot less survival of our tamarisk. Also, during the first year, we realized that we really need to be cutting the stumps lower to the soil surface, such that when you apply that herbicide within that first couple minutes of cutting, that it's being absorbed into the root crown, and then hopefully that way you'll be able to limit survival of the tamarisk that you're cutting. Again, this is what a site will look like when we immediately after mulching and the herbicide treatment. So this is at our our demonstration site at the Pima Bridge. It's one of our largest sites. It's the largest site that we got permitted in that first round. And this is that same site from above. So that picture we just looked at was taken right around here. This next picture that I'm going to show you was taken right around here. This picture was taken in November. So with very, little active re-veg efforts, we're able to see a massive recruitment event behind these cottonwoods. So there are over 150 cottonwoods in about a tenth of an acre area right here. There's also some clonal coyote willows coming in right here, and you've got Gooding willows right there. You may see or may notice that this area looks more densely populated with the natural recruitment, whereas this upper bench is a little more barren. And I'll speak to that in a moment because we are implementing different re-veg tactics for different areas within the river corridor. So I'm going to take credit for all this. This is active and passive re-veg. These are the coyote willow clones that are coming back in on their own. But this is a pole that we were able to put in with a watershed stinger. This is wolfberry or lyceum that we put in on those upper benches. And this is, again, those same coyote willows coming in through that mulch layer. So in order to really implement our active re-veg efforts, we have built a nursery, a native plant nursery at the Discovery Park campus of Eastern Arizona College. This is in partnership with the BLM and Eastern Arizona College, and we are collecting our own plant materials to ensure that they are locally adapted. And we're doing this by basing it off of these provisional seed zones. You can see this is Mount Graham, and this is where a lot of my restoration sites lie. So conveniently, they all lie within the same provisional seed zone, so I don't have to adventure out into different areas to make sure that we're getting the appropriately adapted plant specimens to use on our project. So these zones are based on minimum winter temperatures and aridity, and we are looking into ways to potentially adapt and evolve this program to work within the expected or anticipated potential of climate change. So this is what it looks like once we get out in the field and start collecting a bunch of native plant materials. This is Indian blanket flower, which we use for our pollinator species. We like to incorporate that into our active re-veg efforts because we are within a migration corridor for monarch butterflies. So we'll go out on site, collect a bunch of seed, and then we actually document and tie with these accession numbers all the information related to associated species on site, elevation, and exactly where we took these plant materials so that we can track the success of these mother populations. The resulting database creates a system where planting successes and failures can be more easily diagnosed. So not only are we tracking the accession numbers for where we're getting our plant species, but we're also tracking the different treatments that they receive when we're trying to germinate. So different species may get a different soil mixture or inoculum treatment within the greenhouse. So we want to see exactly the best way to do our germination so that we're having the best success and making the process as efficient as possible. So again, this is a partnership with Eastern Arizona College and the BLM, and again, without them, we probably wouldn't be able to use the native plant nursery as an engine for all of our restoration work that we're doing within the watershed. So after killing probably a few more plants than I'd care to admit, we strategized our planting zones a little bit better. So we took advantage of some existing data that we were collecting for other projects or pre-existing projects and tried to incorporate them such that we were creating planting zones based on rooting depths of each individual plant species. With the help of the folks at Stillwater Sciences, we were able to incorporate Lidar data and our Piezometer well data so we could see whether or not they correlated closely enough to be able to use them to use the Lidar data as a proxy for average or expected depth of the groundwater. So here's our Lidar map, and this was produced by Utah State, and we thank them very much because it was instrumental in determining these planting zones, which we also use to determine, it creates spatial data for us so that we can quantify exactly how many of each individual species we want to put on certain sites, which allows me to tell Justin, our greenhouse manager at GWP, what he needs to get going for me, what seeds he needs to collect. So it's a great trickle-down effect, and it also makes our application of the the active revegetation more strategic, such that we're not, again, throwing the kitchen sink at it and having to do a lot of adaptive management along the way. So we put in, at this point, a series of 18 piezometer wells throughout that 54-mile stretch of the Gila. A lot of this was done at the outset in 2013, 2014 by folks at Northern Arizona University, and I put in about 4 of them myself. A lot of these go down to about 18 feet in depth, and we measure them on a quarterly basis with a water level meter. So this is what our planting zones end up looking like. And you can see that we've categorized them by less than 1 meter, 1 to 2 meters, 2 to 3, 3 to 5, 5 to 10. So you can see within a certain, just the same Pima Bridge site that we saw the aerial imagery of, that you can see the effects of kind of the channelization of the river, because we've got such close areas that to the river channel that are more xeric, more upland. So we wouldn't expect that we'd be able to put in cottonwood or willow poles or other riparian obligate species in these areas, because they'll just dry out. And we can expect that, and I can tell you that because that's what I meant when I told you I killed some plants. So here you can see the coyote willow that's come recruiting through the mulch layer, and we're seeing again how closely it marries to those planting zones. We see that it's coming in exactly where we would expect it to. And we can see the pole that I was able to put in the same type of area. And again, we're putting in more xeric species in those upland areas where the depth of groundwater is further down. This is a mesquite, call it a closely western Johnson grass, and we've got the wolfberry again. And these plants have shown great success in terms of survival. So we're really excited that this planting zone strategy is working well for us. So currently, where we're at in the project is that we have actually treated almost 30 acres with the chainsaw and mulching head initial treatment. And then we've gone back on about 12 and a half of those acres and done secondary treatment, because we are seeing secondary weeds come in. So we will soon have to deal with treating arundo, Russian thistle, that Johnson grass. So there's a lot of maintenance that will need to go into this. So we're using a phased approach where we're doing initial treatment, and then we're going to do a secondary treatment, and then we're probably going to be putting in our active re-veg during that secondary treatment. We are also in the process, and we're waiting for the status of another 404 permit application amendment. So we're hoping to be able to add 350 more acres to that permit, such that we can expand our zone of influence over the course of the next few years. So what's next? We are doing a lot of adaptive management, obviously, and learning from mistakes that we've made along the way. And really, this is our phase 2, where we're focusing a lot on clearing, but also we're working in a lot more of our active re-veg efforts. So perfecting our methodology for bringing in our native plant materials that have been propagated at the native plant nursery, but also using poles such that we can meet our permit requirements as outlined by U.S. Fish and Wildlife. So with that, I'd like to thank a few more of the people who've helped make this possible, both funding partners and permitting partners, because a lot of them have gone out of their way to make this possible for us to work within this window. And with that, I'll be glad to take any questions.